Hello everyone. In this lesson, we will study assembly constraints in NX10 software. Assembly constraints establish a positional relationship between one component and another or multiple components. This relationship is achieved through one or more mating conditions. Only when the constraints between components in an assembly are established through mating conditions can it be considered a true assembly model. Due to the interdependence of these assembly constraints, if the model of an assembled component changes, the assembly part file can automatically update while maintaining the assembly constraints. There are many ways to apply constraints. In this lesson, we will first learn about the assembly constraint dialog box, contact align constraint, vertical constraint, and bound constraint. In the assembly drop-down menu, find component position and click the assembly constraint command. The system will pop up the assembly constraint dialog box. In the type drop-down menu, there are options such as contact align, concentric, distance, fixed, parallel, vertical, align or lock, equal size pairing, bound, center, and angle. Click the contact align type. This constraint is used for two components to make them contact or align with each other. When using this command, the first selected component moves to the selected component. In the orientation drop-down options, there are four choices: preferred contact, contact, align, and auto-determine center or axis. The first option is preferred contact. When this option is selected, both contact and alignment may display as contact constraints. When contact constraints over-constrain the assembly, align constraints will be displayed. The contact option makes the constraint surface face opposite direction in normal orientation, mainly used for contact between two model surfaces. The align constraint makes the constraint surface face the same direction in normal orientation, used for axial alignment between models. The auto-determine center or axis option is mainly used to define coaxial constraints between two cylindrical surfaces, two conical surfaces, or between a cylindrical and a conical surface. After coaxial constraint, the components can still move along the axis. Open the constraint dialog box in component position and select vertical constraint. This constraint makes the target vector direction of the object vertical. We can make a surface perpendicular to another surface, a certain line perpendicular to a surface, or a certain line perpendicular to another certain line. It quickly makes two randomly placed angle surfaces perpendicular to each other. The first selected component moves to the selected component. Open the constraint dialog box in component position and select bound constraint. This constraint is used to weld components together, similar to the union operation in the modeling environment. To use it, select at least two assembled components for the operation, or you can select all components. After bonding, when one component is moved, the other will also move. In this lesson, we mainly discussed the types of assembly constraints and how to use three specific constraints in different environments. Please practice more after class to become proficient in the operation. See you in the next lesson.
Hello everyone. This lesson introduces the equipment constraints. Since sections 15, 16, and 17 are all equipment constraints, and the equipment constraints are all in the same dialog box, so I won't talk about it separately. Then open UG first. Build a new equipment body here. Drag in the pre-built model. Scatter is all chosen here. Click OK. Then two graphics have been dragged in. You can move it first. Choose the direction. Just drag it out. This is the order. Then let's start adding constraints to it now. That's the order. The first constraint, touch. Then there are 5 sub-options. Then look at touch first. It means, as the name implies. For example, select this sideline. Then select this sideline. Give it this sideline to touch together. Of course, you can also choose faces. Next, align. It means, look, this axis can already be displayed. Click on this axis and then click on this axis. Come in again. Click on this axis and then click on this axis. But it's not aligned now. Maybe it's because some equipment is duplicated. Then let's delete these. Then do it again. Click on this axis. Click on this axis again. Then these two axes will be on a straight line. This is alignment. Then this is. Automatically judge the axis and center position. What does it mean? That is, you need to click this axis manually before. But after you entered this order, you click on this side. It can also identify this axis. And then you click on this. It can also align them. I'll separate them first. This is more intuitive. It's okay just like this. After this command, you don't need to click its axis manually because sometimes it's hard to choose. Then look at the first preferred touch. What does it mean? It is in this command. It is equivalent to the combination of the two commands of touch and align. It will automatically judge whether you choose an axis or a touch surface to determine whether the constraint it adds next is touch or alignment, equivalent to the combination of two. Then I won't go into details here. Then this order is over. Then look at the next one, concentric. Concentricity is very similar to the first constraint. Click on this sideline, and then click on this sideline. Let them touch again. If only it needs to be aligned, then just click on the first one if you need to align it, and make touch constraints. Then you click on this. This is clicking on the sideline. Then click here. You can align it and touch it again. Then look at the third one, distance. Distance, as the name implies. Click on this surface and this surface to add a distance to it. If you add a 10 to the value, then the distance between these two faces is 10. At the same time, it can be reversed. Enter a negative number. Then the next one, fix. What does fix mean? Before we talk about fixing, I need to introduce something to you. Is that in the process of adding constraints, the first object that you first click on, and the object that you restrict with it, which need two objects. The first one you click will move. The second one is not moving. Is which you click first, just want it to move. Then the second one is fixed. But if you add the command fix, Add here, for example, add 1 to this. After application. And then if I click this distance again, I'm still the first one. This is the second one. I'll add another one. Then the second object moves. Because fix has a higher priority. The second is the one that clicked first. If you add the fix command, you don't have to think about who ordered first and who ordered second. That's what it means. And then some others. For example, parallel. As the name implies, if these two are not parallel, you click on this surface. They are parallel. Add a parallel constraint. Then these two faces are always parallel. Then the next one, vertical. It's the same as being parallel. Let me show. Click vertical. These two faces are vertical. Then, align and lock. What does this mean? After I entered this order, for example, adding these two, after alignment, well, it's not good to overlap. After this alignment, it seems to be very similar to the previous second command, concentric. But unlike it, this figure can't be rotated after aligning. Because when rotating around this axis, its axes are also aligned. But after this command, align and lock, after the addition, these two relative positions are fixedly locked. You can't rotate anymore, but can be rotated after adding the concentric command. That's what it means. That's the only difference. And then, bone. What does it mean? I won't demonstrate it, because this can't be seen either. Bone means that after adding, then these two objects are equivalent to being stuck together, is equivalent to becoming one. That's what it means. Then, center. Combine PPT. I don't have a model here. What does the center mean? Look at the picture below. Let me zoom in. The center means that there is 2 to 2 here, a left surface and a right surface. Then the part below here is also a left surface and a right surface. For 2 to 2, first, select two faces of a part. Then select two faces of the second part. Then the plane between the two faces of the first part and the plane between the two faces of the second part will be aligned on a plane. It's equivalent to moving it to the middle. Then for 2 to 1, it is this one that can be regarded as a plane. Then this too. If you want to align the plane between the two faces of this part with another existing face, choose 2 to 1. 1 to 2 is the same. Whether 1 to 2 or 2 to any is all the number of surfaces. And then it's over here. Angle. This can be demonstrated. If you want to give it an angle, for example, click this surface, and then click this surface. You can enter any angle here. Enter 10 degrees. Then the angle between these two faces becomes 10 degrees. That's all commands. What is left unsaid is something uncommonly used. Then I won't introduce it. Then you can have a look at these 3 PPT. There are some command parsing next to it. I won't go into details here, so that's all for this class. Thank you all.